Hello everyone. So today we are here with a new video, which is basically on a very new topic, that is conic sections for class 11. And I hope this is a chapter which many of you feels difficulty in understanding and how to operate with respect to each of the conic sections. So today we are going to see this video in a very simple fashion, and we'll understand first the very basic concepts of each of the conic sections, and we'll also see few particular problems, and I hope after that you all will find the chapter easy and scoring. Okay, without wasting any time, let's start with the topic.
Okay, so I'm Michael Dutta. You're watching GANITMATICS. How har sawal hoga solve. Okay, those who are new to this channel, you subscribe to the channel so that you don't miss out on any new videos.
So let us take a line like this. Okay, so this is a line which is a fixed line. Okay, now with respect to this, let us take another line like this. Now think that these two lines are intersecting at this particular point. Okay, now the line that I gave you all vertically, that is a fixed line, and the one that is black is basically a line which is going to revolve about this fixed line at that point of contact, right? Now, so this line that will rotate around this particular straight line which is fixed, I told you. So don't you all feel that if it revolves, then it will look something like this? If we visualize as a whole after it complete the entire rotation, won't it look like something like this? Right? So after it rotates, and even though it keeps on rotating, so we'll get something like this. Now let us observe that what is it. Now you all have done cone in class 10. So you all know what right circular cones are. So if I observe this figure, then I think you all will be able to understand this much, that this is basically a right circular cone, but not one right circular cone. There are two right circular cones, right? So that's why this as a whole is called a double right circular cone. That is, I think, pretty clear to all of us. Now, this line that was initially the fixed line, this is called the axis of the cone, the line which was fixed. And the line which was rotating is called the rotating line. And you all can also call it as the generator of the cone. Okay, so basically this line is generating a cone due to its revolution around this fixed line. Okay, now this right circular cone that we all are getting, the double right circular cone, as you all can see, there are two parts, right? One is the upper part, one is the lower part. Now, if I just observe the upper part, only the circular part, then this part is called as the upper nap. And this lower one is called the lower nap. Okay, so this is basically a double right circular cone, and the basic of the conic section, or the basic discussion of conic section, starts from this. So now we are going to discuss each of the cases that we are going to face, and we'll also learn that what a section is all about. So this is what we have. We have a double right circular cone. Now let us think about a scenario. Now suppose if we have a plane with us. Now that plane can be anything, right? Now suppose we have a rectangular plane, and suppose if I intersect a plane with this particular right circular cone, that what is going to happen, that is what I want to see, right? So I'll give you a few situations where I'll show you that what are the different things that we are going to get if we intersect a particular plane, a rectangular plane, with this double right circular cone. Now think about it, that if a plane intersect with this, then obviously we are going to get a common portion, right? And that common portion that we are getting will be called as a section. Okay, so now see, let's see the first situation that we have here. Okay, now in this first situation, don't you all think that in the first situation that we all can see here, that is situation number 1. So what is happening? That a plane is intersecting with with this double right circular cone. And in that case, I hope you all can see that outline that is shown with the green, right? That is the common portion. And doesn't it looks like a circle if we visualize that in a 3D, right? So that means if a plane is intersecting with the cone in such a way that is shown in the first scenario, then we are going to get a circle, right? Now let's see the second one. Now suppose if the same plane is intersecting with this double right circular cone in a slanted way like this, then I hope you all understand that we are getting a figure something like this. Okay, now come to the third one. Third one, we can see that the plane is intersecting with this double right circular cone, but it's only intersecting with any one of the naps. Remember, in this case, it's intersecting only with one of the naps. Like in this case, it's with the lower nap, so it might do it with the upper nap also. And in that case, we are getting a shape like this, which is shown with the outline, green outline, correct? And in the fourth scenario, you can see that the plane is intersecting with the double right circular cone with both the naps together. And so that's why we are getting two curves, one for the intersection with the upper nap and one for the lower nap. Okay. Now, each of these sections we are going to name, and we'll first learn that what each of these sections or common portions are known as. Okay. Now, see the first one. Now, the first one that we have seen, this is the case where we are getting something like this, which is basically a circle. It's a circle in 3D. And therefore, this is the case when we get a circle. So that means circle is the first scenario, and this is also a conic section. So this is the first conic section we have is a circle. Okay, now let's move to the second one. Now the second one, if I take out that particular common portion outside, then you will see it will look something like this. Okay, and this one is called the ellipse. Okay, so this is the second conic section that is called the ellipse. Okay, we must have heard in our day-to-day life that this figure is looking something like an elliptical. So what is elliptical? Ellipse. This is the figure. Okay. Now coming to the third one. So the third one, if you all visualize, it's looking something like this. So a figure something like this, a curve something like this. This section is basically called as a parabola. Okay. So remember, this is the parabola. But yes, parabola only doesn't look in this way. It may be oriented in other ways also. Later on, when we'll discuss parabola in detail, then I'll show you all that what are the different scenarios of parabola that are possible. And according to each of the situations, we'll discuss separate cases for those different situations. Okay. Now coming to the fourth one, as we can see here that the plane is intersecting with both the naps. And for each of the naps, we are getting something like this. So one here, one here. So together, this entire conic section, the fourth one is called as a hyperbola. So that means initially, if I discuss about the four types of conic sections that we have, the first one is the circle, the second one is the ellipse, the third one is the parabola, and this fourth one is the hyperbola. Okay, so I hope the basic intersections and the conic sections that we have got in these four different situations is clear to all. Okay, so now let's get back to our double right circular cone. Now see, in this right circular cone, the angle that the generator makes with the axis, we are denoting that as alpha, and the angle that the intersecting plane is making with the axis is called the beta. Now, with respect to two figures, we are going to see different situations, or four situations that we all have just now have seen in the illustrations. So with respect to that, we are going to study that how alpha and beta is going to change, and in which situations of alpha and beta we are getting those conic sections. Okay, so let's see. Okay, now the first case. Now in the first case, which is our circle. Now in this scenario, we'll first see that what are the different conditions with alpha and beta this particular conic sections are forming. Okay, so in the first case, it's when beta is equal to 90 degree. Okay, so you all can see that this beta was what? Beta was the angle between the plane and the axis. So you can see that this axis is making a 90 degree with this intersecting plane. So that's why If beta is equal to 90 degree, then the section will be a circle. I think that's pretty clear. Okay, that you all can make a note. This is the first case. This is the first scenario. Now coming to the second one, the second case. Okay, now in the second case, as we can see that this is the angle which is beta that the intersecting plane is making with the axis. And obviously we can see the alpha here. So this is the case that if beta is less than 90 degrees, this is very important that this beta have to be less than 90, but at the same time greater than alpha. Then the section will be ellipse. Okay, then the section is going to be an ellipse. You all can make a note of this. Then the third case. Okay, now the third case. Now the third case says, like suppose if this is my axis, okay, then obviously as we know this is my alpha and this is the angle between the intersecting plane and my axis, so this is my beta. So in this case, if alpha is equal to beta, then as we have seen, so this is when we'll get a parabola. Then the section is a parabola. This you all can make a note. And similarly, in the last case, that is the fourth case, if beta is less than alpha and if that beta value is greater than or equal to 0, then we'll say that the section is a hyperbola. But we have to keep one thing in mind, that hyperbola is when we are only just talking about the curves of intersection, means only this part, okay, only this part, the curves of intersection, these two. So this will be our hyperbola. Okay, now we'll see few degenerated conic sections and one by one the different scenarios we are going to discuss. So degenerated conic sections. So what are those? So these are few special cases that we all are going to learn here. Now let's see the first case. Now this case will arise when alpha will be less than beta and that is less than or equal to 90 degree. So as you all can see that the intersecting plane is basically passing through that point of intersection. And that point of intersection, which I forgot to tell you all before, that point of intersection is basically called the vertex. So that means if our intersecting plane passes through the vertex of the double right circular cone, then we get a point. As you all can see, right, that the intersecting part will be only a point, right? So that means in this case, our conic section is basically just a point. Okay. Now coming to the second scenario. Now in this scenario, what is happening? That beta is equal to alpha. That means the intersecting plane is in such a way that it is having an intersection just along the line of the generator. And in that case, what will happen? As you all can see here, that we are getting a straight line, right? So in that case, in this case, basically, we'll get a straight line as a conic section. Okay. Now this was the second special case. Now moving on to the third. Now if we see the third case, now this is when basically beta is less than alpha and that value is greater than or equal to 0. Then this case, if you see the intersecting place in such a way that we are basically getting a pair of straight lines. See all of you, a pair of straight lines. So these are the two pair of straight lines that we get, and that will be basically the common part with these two naps. Okay. These are the three special cases that as I was basically talking to all of you regarding these are the three special cases, and these are basically known as the degenerated conic sections. Okay. Yes. Okay, so now we will focus on each of the conic sections one by one. So we'll first start with the first one, that is a circle. A circle is a very easy part. The 2D concept you all have already done in your class 10. Now the basic equation of a circle that we'll see here, right? Equation of circle with center HK. So we'll see the equation of circle here. So for any center, you can use this one, and the radius is R. then the equation will be x minus h whole square plus y minus k whole square, and that is equal to r square. So this is going to be the equation of a circle. So we all have to know this general equation, and using this we will also see few basic sums from Ncrt. Okay, so I'll show you all one question from this. I'll just give you all the basic idea so that you can you will understand that how we are going to apply the concept of conic sections in our problems. Okay, let's see the question. It says that find the equation of the circle whose center is half comma 1 by 4 and radius is 1 by 12. This is question number 3 of exercise 11.1 of the Ncrt. Now, since we already know the equation of the circle, so we are going to use it. So we'll say therefore equation of circle. Now, this is very simple. We just need to simply substitute in our general equation as we already know. So it will be x minus half whole square plus, if I use the formula, so it will be y, the equation of the circle, plus y minus 1 by 4 whole square, and that is going to be 1 by 12 whole square. Now what we can do here to simplify this, we all can do LCM here. So in that case, it will become 2x minus 1 by 2 whole square. This will become 4y minus 1 divided by 4 whole square, and that is equal to 1 by 144. Now bring it outside. So it will be 2x minus 1 whole square by 4 plus 4y minus 1 whole square by 4, and that is equal to, sorry, this will be 16, and that is equal to 1 divided by 144. So if you all do the LCM on the left side, you all will see 16 will be the LCM. So it will be 4 multiplied with 2x minus 1 square plus 4y minus 1 whole square, and that is going to be 1 by 144. Now 16 will directly cancel 144, and that will be 9 times. After this, what you all need to do is just simply split in the formula of a minus b whole square, and then cross multiply and bring everything to one side. Okay, so I'm not showing the entire calculation that you all will be able to do. So I'm just telling the final form. After splitting, cross multiplying and bringing everything to one side, you all will finally get 36x square plus 36y square minus 36x minus 18y plus 11 equal to 0. So this will be our equation of circle. So we have something, if we have a question something like this, then we are going to approach it in this way, just simply using the equation of the circle. Okay, so now let's see another equation which is going to be a bit different. So let me show you all that question. So same exercise, let me show you all question number 11. Now let's read the question first carefully, that what they are asking for. So it says that find the equation of the circle passing through the point. So they have given 2 points, one is 2, 3 and one is minus 1, 1. And they have also mentioned that and whose center is on the line x minus 3y minus 11 equal to 0. So what we'll do here is, let us just simply first assume the equation of our circle. So let's write that let the equation of the circle, this is going to be a bit different. Okay, so let the equation of the circle be, as we know the general form, it's x minus h whole square plus y minus k whole square, and that is equal to r square. Okay, now first of all, since this circle is passing through those 2 given points that they have given, so we are just going to substitute. So obviously that means these 2 points are going to satisfy this. So we'll just simply substitute them one by one, and let's see what forms we all get. So for the first point, what we'll get then, it will be 2 minus h whole square plus 3 minus k whole square, and that is equal to r square, right? So this will be our first equation. Now let's substitute the second one. So it will be minus 1 minus h whole square plus 1 minus k whole square, and that is equal to r square. So let's mark it as equation number 2. Now one more information, as just now we have seen, that the center is also lying on this line. So that means the center will satisfy this. So that means h minus 3k minus 11 is going to be 0, isn't it? Or we can also write in this way that h minus 3k is equal to 11. Let's mark this as equation number 3. So that means basically what we all have got here is that we all have got three relations here. One that we have marked as equation number 1. So basically we have three equations with three unknowns, H, K, and R. And if I want to find the equation of the circle, I will need the values of all three of them. So that means I have three equations, I have three unknowns, and I have to solve them. Okay. So let's see one by one that how we can solve them. Now let us first start with the first one. So what I'm going to do here is I'm going to bring everything in terms of one variable. So this value that we have received here, so I think we can also say from here that h is equal to 11 plus 3k, right? This value of h I will substitute in equation 1 and equation 2 separately, and we'll see what we'll get from there. Okay, so we'll write it like this, that from 1 and 3. So simply in place of h, we all substitute 11 plus 3k. Understood? And then solve it. After you all substitute this value of h in place of here, then obviously the entire equation will convert in terms of k. So you all can do it. I'm not showing the entire calculation, but after substituting and solving, okay, you all will get something like this. It will be 10k square plus 48k plus 90 is equal to r square. Okay, and let me mark this as relation number 4. In the same way, we'll substitute this value of h in the second equation also. So that means from 2 and 3. So in the same way, after you all solve, you all will get something like this. It will be 10k square plus 70k plus 145, and that will be equal to r square. Let me mark it as relation number 5. Now, if I see 4 and 5, they both are values of r square, so obviously they are going to be equal. So that means obviously if I equate them, I can definitely equate them. So that means 10k square plus 48k plus 90 will be same as 10k square plus 70k plus 145, right? So 10k square and 10k square will cancel on both the sides. Now I'm just going to solve it as a normal linear equation. So bring the k terms to one side and bring the constants to one side. So you will see you all will get 22k equal to minus 55, which means k will be equal to minus 5 by 2. So we got k, and if we got k, this in decimal will be minus 2.5. Then we can find h also from this relation. So h will be how much? That will be 11 plus 3 into minus 2.5. That will be 11 minus, this will become 7.5, which will be 3.5. So we got h and we got k. Now, in any one of the relations, either 4 or 5, just simply substitute the values. If you do so, you all will get r square as 32.5. So now I have h, now I have k, and now I have r as r square as well. So I'll just simply substitute in the general form. So our equation of circle will become, it'll be x minus 3.5 whole square plus y minus of minus 2.5, that will become plus 2.5 whole square, and that is going to be equal to r square, which is 32.5. Now if we split and if we bring it to one side, then the final equation will become x square plus y square minus 7x plus 5y minus 14 is equal to 0. So this will be our final equation of the circle. So I hope these two, after seeing these two questions, the concept of circle is pretty clear. So after this, now we will proceed further to the next conic section. Okay, so next we'll start with the parabola. Now, to first understand regarding what parabola is and how it's created, let's understand the situation first. Now, for example, suppose we have a fixed line, right? Suppose this is a fixed line that I'm taking here. And suppose this is a fixed point. Now, if I take a point somewhere in the middle of this point and in this line, in between this point and this line, in such a way that the distance of this point from the given fixed point and from this given fixed line is same. I repeat once again. So initially what I told you all, that I have a fixed point which I'm marking with red, and this is one fixed line that I have made. So if I take a point in such a way that it is going to be at the same distance from the point and from the line, okay. Now let me take another such point which is satisfying the same criteria, that the distance of this point from the fixed point and from this fixed line is the same. Okay. Now suppose again I'm taking another point here, and for this point also the distance from the fixed point and from the fixed line is the same. So in this manner, all such possible points which we might have, those distances from this fixed point and from this fixed line is same. And if we join all of these points, then we'll get a curve like this. And that is what is a parabola. So that means basically parabola is the set of all those points which are equidistant from a fixed point and equidistant from a fixed line, right? But you have to remember one thing, that all of these points have to be on the same plane. Then only this curve will be called as a parabola. Now, this fixed point that I was discussing earlier, this is basically called the focus of the parabola. And the fixed line that I've told you all initially, that is called the directrix of the parabola. Okay, so I guess focus and directrix is clear to all of you. Now, let's see another figure to understand the rest of the parts of a parabola. Now, so this is my directrix and this is the line. Now, let me first tell you all regarding this line. Now, the parabola will be always symmetrical about a line. So for this parabola, obviously, I think you all will agree with me that this is going to be the line which is with respect to which the parabola is symmetrical on both the sides. So that's why this line is called the axis of symmetry. Okay. Now, this one I already told you all, this is my directrix for the parabola, right? Now, and the fixed point that we all have marked earlier as well, that is the focus. Okay. Now, you all can see here that this parabola is basically touching the axis of symmetry at one point. This is the point, right? So this is called my vertex. And if I draw a line in such a way that which will be passing through this focus and at the same time perpendicular to the axis of symmetry, then that line will be called as the lattice rectum. So that means what are the things that we have discussed here? What are the different parts for a parabola? We have seen what is the focus, we have seen what is the directrix, we have seen what is the vertex, and we have also seen what is the lattice rectum for the parabola. So I think the basic parts are clear, right? Now we are going to see the different forms of parabola and the standard equation of parabola as well for a few specific cases, and also the general case also we are going to discuss. So let's move on to the different forms of the parabola. Okay, now let's start with the 4 different situations of parabolas that we might face. Okay, now, but before starting with these 4 forms, let me tell you all that these 4 forms we are discussing when, this is very important to know, that this is when the vertex is at origin. This is very important, that the vertex, when the vertex is origin and axis of symmetry is either x-axis or y-axis. Okay, so that means these 4 situations that we are discussing right now, these are specific cases. Okay, general case we all will see after this. So that means this is only the case when the vertex is the origin and the axis of symmetry is either the x-axis or the y-axis. Now let us first see the first situation. So if my parabola is in this way, okay, where you all can clearly see where the x and y axis are. Now, if I consider that the distance of the focus from the origin is a units, if I consider that, that means obviously that's pretty clear that the since the focus is on the axis of symmetry, so obviously the coordinates will be a comma 0. That's pretty clear, right? Now, in this scenario, what is going to be my equation? Let's write that. So in this case, the standard equation of parabola will be y square is equal to 4ax. Now focus is already mentioned here, and see, if this is a, then obviously we know that any point, now since this point is on the parabola, so obviously it will satisfy the condition of a parabola, so it should be equidistant from the focus and from the directrix. And in that case, if this is my directrix, then obviously then this point should be how much then? It should be obviously at a distance of a from origin. So that means this line equation will be what? It should be x equal to minus a. So that means in this case, the equation of the directrix will be x equal to minus a. Okay, now let's move on to the second case. Now, if my focus is on the left side, that is towards the negative direction of the x-axis, then obviously that means the coordinates will change to minus a comma 0, right? In this case, the standard equation of the parabola will be y square equal to minus 4ax. And in that case, obviously the directrix will be on the other side towards the positive side. So the equation of the directrix will be x equal to a. Okay, now coming to the third situation. Now in this scenario, the focus is on the y-axis, because this time the axis of symmetry according to the parabola is the y-axis. So in this case, as we know, f is obviously on the y-axis, so the distance, if the distance of the focus from the origin, if I consider is a units, so obviously the coordinates will be 0 comma a. And in that case, what will be the directrix then? Obviously it's on the lower side. That means the equation of the directrix will be y equal to minus a. And in this case, the standard equation of the parabola will be x square equal to 4ay. And coming to the fourth one is just the opposite case when the parabola is upside down. In this case, the standard equation will be x square equal to minus 4ay. Focus is pretty clear. You all can see it's already marked here. So obviously the directrix will be on the upper side. And in that case, the equation of the directrix will be y equal to a. Okay, so these are the four scenarios, and in these four scenarios, these are going to be the standard equation of parabola. But remember, this is only when the vortex is origin and the axis of symmetry is either the x-axis or the y-axis. But now we'll also discuss the scenario when we have the general case. Okay, so let's discuss that. So the general case is that if the vortex is any point, so if the vortex, let me take it as hk, and let me consider that lattice rectum is 4a. Okay, so in that case, if axis is parallel to x-axis, in that case, the equation of parabola will be this. It will be y minus k whole square. You all can make a note, and that will be equal to plus minus 4a x minus h, depending on the situation in which parabola is in. And the second case, if the axis is parallel to y-axis, in that case, it will just be the opposite. So in that case, the equation of the parabola will be x minus h whole square, and that will be equal to plus minus 4a y minus k. And I've also told you all that what is going to be the lattice rectum of the parabola. That is the formula for lattice rectum, and that is 4 times of a. Okay, so these are the few things that we all need to know for the parabola. And based on this, now we are going to see one sum based on this concept. Okay, so let's see the sum. Now the sum that we are going to see now is from exercise 11.2 of Ncrt. So let's see. So first we'll see a very basic sum. Let's see question number 1. So they told us to find the coordinates of focus, axis of the parabola, the equation of the directrix, and the length of the lattice rectum. Now let's see the equations. Y square equal to 12x. Now whenever we are getting a question like this, the first thing that you all need to do is you first see that this is basically in which form. So out of the 4 forms that we have seen, this resembles which of the form that we have to first see. So I think this much we all can understand is basically the first form that we have learned. So if I imagine this equation in this way as 4 into 3 into x, okay. So if I compare this with y equal to 4x, then we all will clearly we can understand the value of a is 3, correct? So that means obviously we can say the focus. So focus will be, the coordinates of the focus will be 3, 0, isn't it? Because as we know for this situation, the focus is a, 0, so a is 3. So the focus will be 3, 0, right? And in this case, as we know, the axis of symmetry is x-axis. So we'll mention that axis of symmetry is x-axis. That will conclude. Now, what else they are asking? They're also asking the equation of the directrix. So in this case, as we know, the equation of the directrix is on the negative side. So it should be x equal to -a. So in that case, it will be x equal to -3. Pretty clear, I guess. And then the length of the lattice rectum, as we all know, the formula of lattice rectum is 4 times of a. So in this case, it will be 4 times of 3. So that will be 12. So these are the 4 things that they have asked. So we can easily do it in this way. Okay. I guess quite clear. Now let's see another question from this exercise. So let's see question number 12. It says that find the equation of the parabola. Now we have to find the equation of the parabola with the help of the given situation. Vertex they have given is 0, 0. So that means it's the origin itself, passing through the point 5, 2 and symmetric with respect to y-axis. Okay. Now, since they have told that the axis of symmetry is y-axis, so that means it will be either form 3 or form 4. So let us start in this way. That since the parabola is symmetric about y-axis, so that means obviously this much we can say that equation of parabola is either x square equal to 4ay, or we can say x square equal to -4ay, right? Now it's saying that since it is passing through 5, 2, now this is a hint that they have given. Now, if the parabola is passing through 5, 2, now 5, 2 is a point which is somewhere in the first quadrant, isn't it? So if the parabola is passing through this point, that basically means obviously it's the upper part, it's above the horizontal axis, isn't it? So that means obviously it's going to be the third form. So that means this much we can say that therefore equation of parabola is going to be the third form, which is x square equal to 4ay. Now, since this parabola is passing through 5, 2, so obviously 5, 2 will satisfy this. So let's substitute 5, 2 here. So it will become 5 square equal to 4 into a into 2. So that means a will be 25 divided by 8. We got the value of a, right? Okay. Now, so we can substitute it. So therefore, equation of parabola is very simple. Just simply substitute this value of a there. So x square will be equal to 4 into 25 by 8 into y. These two will cancel out and we can cross multiply. So 2x squared is equal to 25y. And this is my required equation of parabola. So this is how we can approach this type of question. So I hope now parabola is quite clear. Now we'll move on to our next concept, that is the ellipse. Okay, so now next we'll start with ellipse. Now, to understand the concept of ellipse, let us start it in this way. Suppose we have 2 fixed points given. One here and the another one I'm marking here. Okay. Now, if I take a point, say here, okay, and the 2 fixed points that are given, let me mark them as F1, F2. And the point that I've taken now, this one, let me mark it as P. So obviously this point we will have a distance from F1 and we'll have a distance from F2, right? Let me take the sum of these 2 distances. So it'll be PF1 plus PF2. Now I'm taking another point Q somewhere here. And again, I'm joining this point with the 2 fixed points, right? So basically, this second point that just now have marked For that point also, obviously we'll be having distances from the two fixed points, that is QF1 plus QF2, right? Now, if the sum of the distances of the point P from these two points, if that is same to the sum of the distance of the second point Q from these 2 points, and if we keep on taking such points which will satisfy the same distance, right? So that means if I take another point, then its distances, the sum of its distances from the two fixed points, if that is also same, then obviously we can get more points like this. Okay. And if I take collection of all of these points for which the sum of the distances from the two fixed points is same, then, and if I join all such points, then we'll get something like this, and this is an ellipse. So that means if we like say the entire thing in one line, it will be that ellipse is basically the set of all points in a plane. That is very important. It should be in a single plane. Okay. The sum of whose distances from what? From two fixed points. Okay, like the way we have done before, from two fixed points is constant. So it's same for all such points. Then it is an ellipse, right? And we can see that in front of us. So this is the basic idea of an ellipse. Now, if I give you all a label figure for ellipse, then we'll be able to also understand the different parts of it. Okay, so suppose this is the ellipse, and suppose this is my horizontal axis, and these are my two fixed points, F1, F2. Okay, now if I join the two fixed points that were given initially, then the midpoint of this line segment is basically called the center of ellipse. Be very clear about it. Okay, now, so in this label figure, let me also draw the vertical axis as well. Okay, and this is my center where the two axes are meeting. Okay, let me mark it as O. Now, the points at which the ellipse is touching the horizontal axis, this point and this point, these are called the vertex for the ellipse. Okay, I think there is no problem with that. Now, if I name the two axes, then I think you all can see that in this ellipse, if I just see the inside of the ellipse, then out of these two axes, one is bigger, one is smaller. It's quite simple. So obviously, according to this figure, the horizontal is looking bigger. So this one, that's why it's called the major axis. Okay, and the smaller one, which for this instance is the vertical, is our minor axis. Okay, and we also denote the entire major axis as 2a. So that is why the distance on the left is a, on the right is also a. Same goes for the minor axis. We denote the entire distance as 2b, and therefore this upper length is b, and this lower length is also b, because the figure is symmetrical all around. Now, the distance of the center from the two foci is c each, and therefore the total length of F1, F2 will be twice of c. Okay, so these are basically the major parts of our ellipse. Now, after this, one more term we all need to know here is the eccentricity. Now, what is that? It's basically, we denote the eccentricity by small e, and it's basically the ratio of c and a. So that means it's basically the ratio of the distance of the center from one of the foci and one of the vertices. So as you can clearly see from the figure that the distance of the center from the foci is C and from the vertex is A. So that's why it's the ratio of these two things. So if we need to find eccentricity, we can go for this form. Okay. So now this is the basic concept regarding ellipse. Now we are going to see the forms of the ellipse. But yes, first we'll see the specific forms, few particular cases, and then we'll also see the general case. So let us first start with the special cases. So this is when the center is at origin and foci are on the x-axis or on the y-axis. Okay, so let us first see the first case. And for that, we have to first see the figure so that it becomes clear to all of us. So suppose these are the two axes. And suppose if the ellipse is oriented in this way. In that case, let me mark the points as A and this one as B. This one as C, this one as D, just to understand. This is my center marking as O. These are my foci, F1, F2. If I consider the distance, which we already have discussed in the earlier one, so this is my C, so obviously the coordinates of F2 will be C, 0, and on the negative side will be minus C, 0. That's pretty clear, I guess. So the standard equation of ellipse, in this case, it will be x square divided by a square plus y square by b square, and that is equal to 1. So this is my first case. Okay, now just the other case that we are going to see is when it's oriented in a different way, when it's something like this. See, now suppose if my ellipse is like this. So obviously in this case, you all can understand this much, that the major axis will be along the vertical, because along vertical axis, the axis is bigger, right? So that means obviously one of my foci will be here, and in that case it will become 0, C as it's on the y-axis, and my F2 will be 0, minus C according to the coordinate geometry concept, right? So, and obviously the x and the y-axis are marking, so that it will become clear that O is basically my origin. Okay, so in this case, my standard equation of ellipse will be, see what is the difference in this case. So it will be x square by b square plus y square by a square is equal to 1. Okay, but keep that in mind that in both the forms, A will represent the half of the major axis, that is semi-major axis, and B will represent the half of the minor axis, which is also called as the semi-minor axis. So these are the two specific forms. Now we'll see the general form. So the general form is, you can write it in this way, that if the center of the ellipse, now the general form, if that is at h, k, any general point we are taking, and the directions of the axis are parallel to the coordinate axis. Okay, so any one of the cases we might consider. So in that case, equation of ellipse, the general equation will be this. It will be x minus h whole square divided by a square plus y minus k whole square by b square, and that will be equal to 1. Okay, I think that's pretty clear now. And after this, only one small thing is left, and then after that we can start with the sums. So the next concept is the last one from the ellipse part, is the lattice rectum for ellipse. Now to understand the lattice rectum, we again will see the figure of the ellipse in short, and then we'll see where the lattice rectum is situated, and accordingly we are going to understand it. So x and y axis are already marked. You all can see this is our center. So these are the two foci basically. So if I take lines perpendicular to the horizontal axis in this case, passing through the foci, it's perpendicular to the axis and passing through the foci, then the two distances that we are getting, that is in this case AB and CD, these are the lattice rectum. Okay, and the length of lattice rectum we can get using this form. That will be 2b square divided by a. So in the question, if you need to find the length of the lattice rectum, you just simply calculate 2b square by a, and that is how we can get it. Okay, so it's just remember one thing, it's basically the line that is perpendicular to the axis, okay, the horizontal axis in this case, and will be, or we can also say it's perpendicular to the major axis and passing through the foci. Okay, so this line segment, the length of this line segment will be our lattice rectum. Okay, one more thing. Now, in this entire ellipse concept, we all have seen three variables, A, B, and C, which are the main three, you can say the unknowns here. Now, these three are related in this way. So, C is equal to square root of A square minus B square. Now, why we need to know this relation? Because in our sums, if we know any two of these three, then we can find the third one using this relation, which is going to be very, very useful. Okay. So I hope now you all have understood regarding the ellipse. Now, using the concept that we have learned just now, we will see one sum just to clarify our concept. Exercise 11.3 from the Ncrt. Let me show you all one sum, that is, let me show you question number. Anyone, say, let's see question number 4. So it's given, the equation is given as x squared by 25 plus y squared by 100, and that is equal to 1. So bring it in that original form first, that is x squared by 25 is 5 squared and 100 is 10 squared, right? Now here, always remember that whenever we are doing an ellipse sum and we want to know that which form we are going to use, the first one or the second one, we always focus on the denominators. Okay, so if we know one thing, that major axis have to be the bigger one, right? So that means if the denominator of x square is less than the denominator of y square, that means it's the second form. Okay, and if the denominator of x square is bigger than the denominator of y square, that means it's the first form. Okay, because we always have to keep in mind that A have to be bigger than B, because A is the minor, A is the major and B is the minor. So keeping that in mind, we are going to decide. So what we'll say here, that since 25 is less than 100, that means in the second case, so that means major axis will be along y-axis. That we'll first say. Now, they're also asking the foci, vertices, length of major and minor axis, eccentricity, and the length of lattice rectum. So all of these we are going to find one by one. So now we'll say, comparing with that form, the second form, so that we'll mention here, that is x squared by b squared plus y squared by a square equal to 1. So b we can directly say is going to be 5 and a is our 10. So that means we can directly say the vertices. So therefore vertices will be what then? It's 0 plus minus a, right? So that means it's going to be 0 plus minus 10. 10 for the upper one and minus 10 for the lower one. Now, next we'll find the length of major axis. Okay, so length of the major axis according to our concept, as we know, is twice of A, so it's twice of 10, so that will be 20. And in the same way, length of minor axis, which is going to be twice of B, that's twice of 5 here, so that will be 10, right? Now, so out of A, B, and C, we have already calculated A and B. So C we can calculate by the relation just now we have discussed. So C will be square root of A square minus B square. So that will be 100 minus 25, which is becoming 75. And square root of 75 will be 5 root 3. Okay. So that means eccentricity can be easily calculated. Eccentricity is C by A. So that will be 5 root 3 by A was 10. So we can cancel here. So eccentricity is root 3 by 2. And the last thing that we need to know now is the lattice rectum, the length of lattice rectum. So that we'll just use the formula that just now we have learned. That is 2b squared by a. So it'll be 2 into 5 squared by a is how much here? 10. Right. So we'll just simply cancel. So it's coming out to be 5. So everything we have got here. We have told about the major axis. We have got A and B. We got the vertices. We got the length of major axis. We got the length of minor axis. We got the eccentricity. We got C with the help of C. We got A, and then finally the length of lattice rectum. So that is how we approach this type of sums. Right? Okay, clear? Now let's move on and see another question of a different type. Okay, just to clarify. Okay. So next we'll see question number 20. It says here that find the equation of the ellipse with the given condition. Now, what is the condition? That major axis on the x-axis and passes through these 2 points. Okay. Now, if the major axis along x-axis, you already know which form it is, right? So we'll assume it first, that let equation of ellipse be. So we'll assume it as x squared by a square plus y squared by b square equal to 1. The first form according to the given condition. Now they have mentioned that it passes through these 2 points. What are the points given? It's 4, 3 and 6, 2. And we know that if the ellipse is passing through these 2 points, that basically means that these 2 points are going to satisfy it, right? So let us first satisfy the first point here. So how much we'll get? We'll get 16 by a square plus 9 by b square equal to 1, right? And for the second point, which is 6, 2, we'll be getting 36 by a square plus 4 by b square equal to 1. So you're basically getting 2 equations where we have 2 unknowns, a and b. So there are various techniques to solve this. We can apply the concept of substitution here. Let me assume 1 by a square as x. Not x, let us take some other variable. It will be too confusing otherwise. Say m. Okay. And let us consider 1 by b square as n. So this equation will be converted to 16 m plus 9n equal to 1. And this will be 36m plus 4n equal to 1. Now let us solve. So any approach, whatever you all want, you all can solve. I'm not showing that. I'm just telling the final answer. So after solving these 2, you all know very well how to solve this. After solving, you all will get the value of n as 5 by 36. I'll be getting 5 by 65, which will be 1 by 13. And we already know that n is 1 by b square. So that means b square is 13. Okay. Next, and using this value, if you find the value of the m, then m you all will get as 1 by 52. So which means 1 by a square is 51 by 52, which means a square is 52. So we got a square, we got b square, so we can easily get the equation then. So it will be x squared by 52 plus y squared by 13, and that is equal to 1. So this will be our equation of the ellipse. That is how we can do it. So I hope now the idea of ellipse is quite clear. So next we'll move on to the last conic section from this chapter, that is the hyperbola. Okay, now to understand the concept of hyperbola, let us first start with the very basic thing. So let me first take 2 fixed points. Okay, so one is this and one is this. And let me name them as F1 and F2. Okay, like same like the way we have started an ellipse. Okay, now, so let me take a point. Suppose let me take it here and let me name it as P. Okay, so obviously this point will have a distance from these 2 fixed points. These will be the 2. And we are going to take the difference of these 2 distances. In ellipse, it was the sum. Here it is the difference. So obviously, according to the distance that we can see from our eyes, so the difference will be PF2 minus PF1, right? Now let me take another such point, and here also we'll take the difference of the 2 distances that we are getting, right? So that will be in this case QF2 minus QF1. If for these 2 points, both of these differences are same, if, okay, now let me take more such points. Now let me take now somewhere near to F2. Let me name it this as S. So the difference of this point from the 2 fixed points will be SF1 minus SF2. If that difference is also equal to the previous 2, and if I take another one, let me name it as R. Okay, again the same thing, that the difference of the distances is going to be the same like all the previous differences we have seen. In that case, if I join the points separately, the ones which are closer to the first fixed point and the ones which are closer to the second fixed point, then I think you all can understand this much, that we are going to get something like this if I join all these points. So I'll get a curve like this, right? And the ones which are closer to F2, if I join them, we'll get something like this. Okay, right? So this is the combination as a whole. This entire thing that we are getting is our hyperbola. Okay, and hyperbola is basically the 2 curves together. We call it as an hyperbola. And if I join these 2 fixed points, then this line we'll call as the transverse axis. Here, the term is a bit different. We call it as a transverse axis. And the one which is, now let me consider this point, which is the midpoint of F1, F2, and that is will be our center. Okay, and the axis which is passing through the center and perpendicular to transverse axis, that we'll call it as the conjugate axis. Okay, so this is basically our basic understanding, or we can say the idea regarding our hyperbola. Now we'll see a labeled figure so that we can understand all the parts of the hyperbola. So let us first draw the axis. Let us see a separate figure. Suppose these are the 2 axes, the transverse and the conjugate. Okay, and suppose these are the curves that we have got. Okay, these are the 2. And as we can see here, that these are my 2 fixed points, F1 and F2. Now the points at which these 2 curves are meeting, the transverse axis will be our vertex. So the ones that I'm marking with red are my vertex. Okay. So if you want, you can label them as well. And the one that is the midpoint of F1, F2 is our center, marking it as O. Now, so the distance between the 2 vertices will be our length of transverse axis. So that means is this distance that I'm talking about, which is as 2A. So it's A on one part and A on another part. Like this, you all can mark. Okay, and to understand the length of the conjugate axis, we have to understand one thing here that I'm explaining all of you. Now, if I draw a line in this way, may not be exact because, yeah, something like this, which is passing through the center. Now, these line, if you all closely watch, it's basically very close to the figure, but it's not meeting it. So what I mean is if you have a curve like this, right? And if we get a line which will go very close to the curve, but it will not touch it, such a line is called an asymptote to the curve. Okay, so that means this red line that I've drawn, this will be called as the asymptote. Okay, so you can label it in the figure as well. So this is one asymptote, and another one will be on the other way. It'll be like this. So these are the 2 asymptotes. Now, once we are clear with the asymptotes, now, obviously, if we take a line in such a way that which will pass through any one of the vertex and perpendicular to the transverse axis. So what I told, I'm drawing a line which is passing through the vertex and perpendicular to the transverse axis. Then in that case, obviously, this perpendicular line will touch the asymptotes here and in the lower side here, right? And this, through this point of intersection, if I draw a line perpendicular to the conjugate axis, so we'll get something like this, isn't it? So here we'll get a point of intersection with the conjugate axis as well, right? Now this distance from this point to the center, this will be our B on the upper half, and this is also our B for the lower half. And this entire 2B is going to be the length of the conjugate axis. So that means if I now say that what is going to be the length of transverse axis, then we all can say it's going to be twice of A, and the length of conjugate axis is going to be twice of B. And that is how twice of A and twice of B we have already showed in the figure. And I think you all have understood how we got the length of B as well, right? And that is basically with the help of the asymptote concept. So I hope we all are clear till this. Now, one more thing we need to know, and that is my eccentricity for hyperbola. It will be same like we have in the case of ellipse, it's C by A. Okay. And here also we'll see the relation between A, B, and C. So in this case, it's going to be B is equal to square root of C square minus A square. Okay. So these are the few basic things that we need to know about our hyperbola. So next, now we are going to see the standard equation of hyperbola for a few specific cases, and then we'll also see the general case. So let us first see the specific cases. So this is when the center is at origin and the foci are on the x-axis or on the y-axis. Okay. Now, let us see. So two cases we'll have here also. Now, let us first see the figure, and with respect to that, we are going to see. So let me first quickly draw the two axes, that is x and y, like the way we have specified here, right? And these are the curves of our hyperbola. One on this side, one on this side. So in that case, if I talk about the foci, so F1 will be minus C comma 0. Yes, here also it's the same, that the distance of the center from the foci is our C. Okay, same like ellipse. And this side, the positive side will be C comma 0. It's pretty clear. This is my center, which is marked as O, right? And therefore the vertices, this will be A comma 0. And on the negative side will be minus A comma 0. So here, the equation of hyperbola will be, the first case is going to be x squared by a square minus y squared by b square equal to 1. So that is the difference between the form of ellipse and hyperbola. There it was sum, here it will be difference. So this was the first case. Now let's see the second one. It's almost the same. The only difference is the orientation of the curves. So in this case, it will be in the upper part like this and in the lower part. Okay. So accordingly, we'll have the foci one here and one here. Okay. So if I say F1, then it will be 0 minus C, and F2, it will be 0 comma C. And similarly, the vertices, this will be 0 comma A, and this will be 0 comma minus A. So all the concept. Okay, so therefore the equation of hyperbola in this case is going to be, it'll be y squared by b squared minus x squared by a squared equal to, it'll be y squared by a squared minus x squared by b squared equal to 1. Okay. So this will be the two forms. I hope we all have understood the two specific cases. And now we are going to see the general case. So if the center of hyperbola is at HK, as we have seen earlier also. The general case, it can be any point, and the direction of the axis are parallel to the coordinate axis. Then in that case, the general form will have it in this way. So it will be the equation of hyperbola in the general case is going to be like this. So it will be x minus h whole square by a square minus y minus k whole square by b square, and that will be equal to 1. Okay, I hope we all are clear regarding this. So we are left with only one small thing, that is our lattice rectum. So that just quickly see with the help of the figure. Suppose these are the two curves, and if I say that these are my transverse and conjugate axis, again the concept is still the same, that if these are my two foci, F1 and F2. So if I draw lines perpendicular to the transverse axis and passing through the foci, then the lengths of the line segments that we are getting is our lattice rectum, and their length, if they ask us in the question, then we are going to find with this form. So the length of lattice rectum in case of hyperbola is going to be 2b squared by a. Okay, so this is all about our hyperbola. So now we'll see two simple sums and then we'll conclude our concept. So let us see two basic sums from Ncrt. Let us start with exercise 11.4. So let us first see question number 1. It's given as x squared by 16 minus y squared by 9 equal to 1. Now in hyperbola questions, how to understand which form to use? You just see that in the difference, is x square coming first or y square coming first? If x square is coming first, it will be the first form. If y square is coming first, it will be the second form. As simple as that. Now, if I compare, so I think we can clearly understand this is basically the first form, right? So we'll write it in this way, that comparing with, we'll mention the form, that is x squared by a square minus y squared by b square equal to 1. So we are getting quite easily that a is going to be 4 because 16 is 4 square and b is 3 as 9 is 3 square, right? So we have a, we have b. So I think there is no problem in finding c. So c will be square root of a square plus b square, that is 16 plus 9, form of the relation between c, a and b we have already learned a few minutes back. So we are just using that. So it's square root of 25, so it will be 5, c is 5. Now what they're asking us here, the coordinates of the foci. So in that case, we can easily say the coordinates of the foci. So it will be, since our transverse axis is along the x-axis, so it is going to be plus minus 5, 0, like the way we have in the first form. So we got it. And then they're also asking the coordinates of the vertices. With respect to a, it's going to be plus minus 4, 0, right? Next, they're asking eccentricity. Easily, it's c by a. So that means it's going to be 5 by 4. And then finally, the length of lattice rectum, as we know the formula, so we are just going to substitute in that. So it's going to be 2b squared. So it's 2 into 3 squared divided by a, that is 4, right? So we can cancel this. So we are getting it as 9 by 2. So that is how, if the equation of the hyperbola is given, we can find the required details. This is one type of question. And the another type is details will be given. We have to find the equation of the hyperbola. That also we are going to see now. So let us see question number 15. So what they told us to find the equation of hyperbola satisfying these conditions, what they have given us, let's see that first. Foci are given to us as 0 plus minus root 10. And they have also mentioned that it's passing through 2, 3. Okay, no problem. So first of all, what we can say here is that if foci is given, that means c, we can say it's square root of 10, right? And that means c square is going to be 10. Now, one more thing we can say here, that the foci is on our y-axis, because by seeing the coordinate you can understand the x part is 0, it's obviously on the y-axis, right? So we'll say since the foci is on y-axis, so we can understand which form it is. Obviously it's going to be our second form. So second form we are going to use here. So we'll assume it first, that let equation of hyperbola, and then we'll find the unknowns and we'll get it. Okay, so it's y square by a square minus x square by b square equal to 1. Now they have already mentioned that it's passing through 2, 3. So that means obviously 2, 3 will satisfy this equation. So let's substitute. So it's going to be 9 by a square minus 4 by b square equal to 1. Okay, just bring any one of them in terms of other. So suppose, for example, if I bring a square in terms of b square, it will be a square is 9b square by b square plus 4. Just I'm rearranging. I think you all can easily get that. So now we also know the relation between c, a and b, which is this. So let me use this form. C square is 10. We already know that. Now let me write a square as 9b square by b square plus 4 and plus b square. So I got an equation in terms of b, so I can easily find the value of b, right? If we all rearrange and solve, we all will get an equation like this. That is b4 plus 3b square minus 40 equal to 0. Now, since it's a biquadratic equation, but we can take in help of substitution here. Let us assume b square as any variable, say m. So this will become m square plus 3m minus 4. Now just simply factorize this. So if you do the middle term, you all will get the factors as m plus 8 and m minus 5. This will be the two factors. Sure, sorry, this was 40. So product is 40 and we are splitting 3 as 8 minus 5. Okay, and that is how we got the factors as m plus 8 and m minus 5. So that means obviously the values of m you all can see here is going to be minus 8 and plus 5. Now m is a square term because b square m we have assumed. So obviously it can't be negative. So this case is rejected in that case. So that means m is going to be 5, which means b square is going to be 5, right? And if b square is 5, then we can find a square from here. A square will be how much? Then if I substitute, you all can see it will be 5 then. So I got b square, I got a square. So equation of them will be y square by 5 minus x by 5, and that is equal to 1. So this will be our required equation of hyperbola. Okay, so I hope you all have understood the concept of hyperbola and all the conic sections that we have seen with diagrammatic approach, with different situations, different problems also we have seen for all the types of conic sections. So I hope now this chapter will seem quite easier compared to what idea you all have earlier. So I hope you all have enjoyed the video. So you all are watching GANITMATICS. I'm Michael Dutta. That's all. And those who are new to this channel, do subscribe to the channel and hit the bell icon. Thank you. And let's again meet in the next video. Thank you all.